Hi there, Algebra 2. 3.4, Linear Programming. Objective, to solve problems using linear programming. Constraint is a limitation or restriction. Linear programming is a method for finding a minimum or maximum value of some quantity, given a set of constraints. Feasible regions is a set of all points whose coordinates satisfy the constraints of a problem. Objective functions, a function that is desired to maximize or minimize. Vertex principle of linear programming. If there is a maximum or minimum value of the linear objective function, it occurs at one or more vertices of the feasible region. Okay, what point is a feasible region maximizing P for the objective function? Okay, so I'm going to write these over here so I can use my board over here. Yeah. So, we're going to have x plus 2y is less than or equal to 5. I'm going to change that into slope-intercept form, only inequality-wise. So I'm going to minus x. I get 2y is less than or equal to negative x plus 5. Divide by 2, divide by 2, divide by 2. Y is less than or equal to negative 1/2 x plus 5 over 2. Okay, that's one of them. The other one, I would have to minus x. I'm going to start up here. X minus y is less than or equal to 2. Minus x, negative y is less than or equal to negative x plus 2. Okay, and then I'm going to divide by negative 1. Y is greater than or equal to x minus 2. Okay, so there's my other one. And then it says x is greater than or equal to 0. Y is greater than or equal to 0. Okay, so I have both of these. Yep. Move this over here. Okay, so we're going to take these points from over here. First one I'm going to do, I'm going to go light blue. And I'm going to do these first. So I'm going to go x is greater than, well, maybe I won't go light blue. That one looks like it has better there. Good, that's orange again. Okay, so I am going to do 3, or x is greater than or equal to 0. X is going to be 0 right here, and it'll be going up and down. So this one is actually going to have the x right down this coordinate. It is going to be a solid line. Just like that. And you would shade everything over here. I forgot marker today. Yeah. You shade everything over here. Yeah, now we're gonna try this green. Let's see if I can find a couple different colors. Maybe try to go a little darker. So over here we have another line or equal to. So we're going to go right next to the orange here, all the way through. We're going to shade above. Okay. Then we got these other values. You have x -2, so we have one right here. It is with a slope of 1, so they're up. So 1 to 1. And then go down. Let's say 1 to 1. Okay, at this point you would shade above. It is a solid line. So you shade up here. Okay. The other one that you are going to have is you're going to have this x, so you're 5 over 2, which is 1, 2.5. Okay. Then you are down 1 over 2, down 1 over 2. Okay, and you're going to shade below because it's less than. It is a solid line now. So, the area we are looking for in this one is going to be this area right here, where I'm putting the circle. So we're looking at this area. Now, you are looking for the points in which it crosses and intersects and it still fits everything. One of them's right here, one of them's right here, one of them is still getting fit here, and one is going there. If you recall from the board, we have those points. This was our multiple choice they gave us, was these points, the brown points right there. So, these are the points they gave us. Now, we have to see if they work. Okay, so we have graphed all these. Okay, we have 2, 0, which was one of the points, one of the brown dots. We have 0, 0. We have 3, 1. And we have 0, 2.5. All right. So, probably too much of a gap. I'm going to get too close to my board over there. We plug this into this formula right here. That formula right there is where we're going to plug it in. So we got 2x plus y, this equals p. Okay, x is 2, 2 times 2 plus y, which is 0. You're going to get p equals 4. Okay, that's one of them. Okay, here we're going to put in as p equals, sub in my x, I'm going to get 0 times 2 plus 0, so p is going to equal 0. Okay, here I'm going to go p 2x plus y. Well, if I sub that in, I get 2 times 3 plus 1 is 7, so p equals 7 here. And then here you would get, you have your equation again, sub in, you're going to get p equals 2 times 0 plus 2.5. You're going to get p equals 2.5. So, which one of these has a maximum? Maximum meaning largest? Right here. Okay, this one we have the same constraints. The only thing that changes is our formula for finding the maximum. Now, what's taking place here is everything's the same. Our points are still, when I do my constraints of the points that'll work, it'll still be the exact same picture over here on my grid paper over here. So, I basically just have to use this other formula to solve it. So I have p equals x plus 3y. So I'll have p equals 2 plus 3 times 0. P should then equal 2. Okay, over here I'm going to have p equals x plus 3y. Sub it in, you're going to get p equals 0 plus 3 times 0, which should get me p equals 0. Okay, once again we're going to go p equals x plus 3, y. Sub it in, you're going to get p equals 3 plus 3 times 1, which should give me p equals 6. And then I have p equals x plus 3y. Sub in my numbers, p equals 0 plus 3 times 2.75, which would give me 7.5. This one is my answer this time. So, it all depends on what your equation that you're trying to find the maximum is, based off these points. So, that is the basics of it. Testing vertices. Now we're going to make it into a real world situation. Okay? Okay, the first thing you're going to have to do here, okay, is I have to understand what they're asking me. You are screen printing t-shirts to sell at the Polk Country Blues Festival, and they are working with the following constraints. You have at most 20 hours to make shirts and stuff. My picture's a little tough to see here. It takes 10 minutes to make a t-shirt. It takes 30 minutes to make a sweatshirt. If we do this, is it going to, if we do this, I would change it all to minutes. So how many minutes are in 20 hours? Well, you take that times 60, you should get about 1,200. Wrong spot for that. Okay, and that is the greatest amount of time, so it'll be greater than or equal to, okay, 10 minutes per t-shirt plus 30 minutes per sweatshirt. Okay, that equation is done. You want to spend more or no more than 60 or 600 hours on supplies. $600 goes right here. And that's the most you can spend, so it's got to be less than or equal to that. It costs you for supplies for the t-shirt $4 plus $20 for the sweatshirt, if I recall. Okay. At this point in time, you have to, so that's your formula for that. So the second one I've satisfied and made a constraint for that. You want to have at least 50 items to sell. Well, 50 is going to be less than or equal to, because we have to have at least. So you have t-shirts plus sweatshirts has to equal that. Now, the one thing we don't have a whole lot of information on is our profit margin. Well, there's kind of a reason for that. There's also two more constraints we can make here. Can I have negative t-shirts? So T has got to be greater than or equal to S, and S has got to be greater than or equal to 0. Both of them are like that, or they have to. And I think I said this is greater than S. It's T has got to be greater than or equal to 0. Okay. The other thing is, to find our profit margin, we're going to find the spots where these cross and we are going to put it into our profit margin. Well, our profit per shirt is T, or 6T, $6 per T plus, let's see, I think it's $20 per sweatshirt. And this is going to equal my profit margin. With something like this, with this big of numbers, I would probably be okay with you using Desmos. Obviously, you have to understand how to create these to use Desmos. Okay. Okay. At this point, you type in both of your equations. I'm going to change my t's to x's and my s's to y's. Okay, once again, 4x plus 20s, which is y, is less than or equal to 600. Okay, my other constraint is x plus y is greater than or equal to 50. Okay, so I typed all that stuff in there before I changed that. Alright. So, I've typed in my top 3 constraints. I gotta keep going. That's going to be my x. My y is going to be okay. We need to zoom out and probably move. The spot that I would say is getting hit by everything based off the shading is probably this area right here. So we need this point, that point, So the points in which these intersect is right here and here. So I have the points. Why is it frozen? I don't understand that. Alright. So you would have your points 25, 25, and 50, 0. Okay? They are going to go into this. Now, I've only found 2 so far. Let's see if we can find any other spots that crosses. Let's go over to this line. I would say everything crosses in between here and here. So there's my other ones. Those are my 4 points I need right there. Okay. Plug those into this. If I plug 25 into this, I'm going to get 150 plus 500, which would be 650. So that's my first one. Okay, second one I'm going to plug in 50, which will give me 300 plus 0 equals 300. So that one. And do the 75. 75 times 6. Well, 2 would be 150. So if there's 2 more of those, that'd be 450. 15 times 20 should be 300. So that should be 750 when I plug this in. Obviously for those. Okay, 120 times 6 should be 720 plus 0 equals 720. So, this option right here would be my best option for profit margins. Okay. One more here. Right here, now if you it took you 20 minutes to make a sweatshirt, how many of each type of shirt would you make to maximize your profit? Okay? So, all we're actually going to do is this equation right here. We put in 30 minutes to make it, now we're going to make it 20. Okay? Now if I go in here and highlight my points, okay, there's my 2 points. I already have 25, 25, and 50, 0 figured out. I now need to figure out 100. Instead of this, I have to figure out, get rid of those 2. So this one goes here still. Okay, we have 100, and we have 10. Okay, we have 120 and 0, which that was probably already done too. Okay, when I do that, I got 720 for the last one, plus 0 equals 720. Okay, I put in 100 there, I get 600. Okay, 10 times that would give me 200. So that would give me 800. Obviously I made more profits. It is still this one that wins the most. In this case, you'd make 100 t-shirts and 10 sweatshirts. Okay. And there's your homework. It's like a walking fire problem.